Let's look at 6.6, which isn't anything new. It's just in here to recap everything we've talked about so far in chapter 6, which is essentially factoring. So up here, I've kind of outlined, given you a little flow chart for any situation where you know you have to factor. And this is going to be good for chapter 7 as well, because that's all we're going to be doing in chapter 7 for the most part. Right, if we know we have to factor and it doesn't tell us how we're going to factor, right, the first thing you're going to look for in any problem is a GCF, and that should be on your mind all the time. Right, if you don't have a GCF in the problem, our only other way to factor, right, is to unfoil. Right, so we're going to set up two parentheses and try to factor that, whether it be an easy form of unfoiling, a more difficult form, or a difference of squares. They all fit in this unfoiling category, and I kind of have that spelled out over here. We'll look at specific examples as a recap. If you can find the greatest common factor, then yes, great. Write down the greatest common factor and you only end up with one set of parentheses. GCF times what gets me my original polynomial. So with a GCF one set of parentheses, but you're not always done there. When you have a GCF, you have to be wary about what's left over. Can what's left over be unfoiled? Well, if the answer is no, then you're done. All right, and this would be your answer. If the answer is yes, that this piece in here, this polynomial is still factorable, that would mean that you see that you can unfoil it. So if it can be factored any further, you'd have a GCF out front, but this polynomial here would be broken into two smaller unfoiled factors. And this would be your final answer. So here's a nice little flow chart of how your thought process should go when you're approaching factoring of any polynomial. Okay, so over here, let's go through 4 quick examples of of what those would look like. So if I just had a GCF in a problem, it might look like something like that, where we would say, oh yeah, I definitely see something that all 3 of these terms have in common. They're all divisible by 2, and they all have x's in them. So I use the lowest power. They all have an x that I can remove. So just like we said over here, when I notice there's a GCF, I just write the GCF out front, and I have one single set of parentheses letting me know that I have to fill in this blank. 2x times what? We'll build this back up again. So 2 times 3, I need x to the third. These two would build 6x to the fourth. Next term, 2 times 2x squared. 2x times 2x squared would be 4x to the third. And lastly, looks like 2x times 5. 2x times 5 would be 10x. There's just a GCF in here, but though, notice, I mean, once you have the GCF, you want to make sure that that remaining piece can or cannot be factored anymore. Right? And when we're dealing with x cubed, we don't really have a skill set that we've developed in chapter 6 to worry about it. So this one I'm going to call done for now. Right? If you take college algebra, we'll look at ways to break apart an x to the third or an x to the fourth polynomial, but for this chapter 6, it's really revolving around x squared. And since this has more than x squared in it, I don't think this can be factored anymore. So just a GCF here. All right, let's look at an easy unfoiling problem. Let's say x squared plus 4x minus 21. And I call this easy because there is no coefficient. Well, there is a coefficient, it's just 1. The coefficient of x squared is 1. So we can unfoil this, x and x. And in this easy situation, we just need to come up with 2 numbers that multiply to 21, add the 4. So 7 times 3, 21, positive 7, negative 3. 7 minus 3 is positive 4. So And that would be the easiest type of unfoiling. Unfoiling that's a little bit more difficult would be unfoiling that has a coefficient that is not 1 out front. Like this. There's no common factor, so our only option is to unfoil it. Now we have to worry about the first term happening, and this is just 5 times 1, so 5x and x. We have to look at the last piece, 3 and 2 and 6 and 1. We have to figure out which one of those values can go here that'll help us get to 29. Again, none of these in this harder situation are going to add up to 29, and even if they did, it wouldn't mean that it was the correct option. We have to figure out what number is going to play along with this 5 the most effectively to help us get near 29. Okay. If you fiddle around for a second, you're going to find out that 6 is the best case because you can see 5 times 6, right, ending up with a 30. Remember, we like to check our middle term. You can do this mentally or write it down. If we put a 6 back here and a 1 here, we would have 30x. That's a good sign. And in the middle, a 1x. If we wanted to get 29, we would need 30 minus 1. So 5 times 6 is 30, positive, minus 1, and we factored it. So a little bit more difficult to crack that puzzle because that 5 does fiddle around with the whole middle term. And lastly, a difference of squares. You can identify a difference of squares pretty easily. Because there are only 2 terms. The middle term with the x in it is missing. All right, another way to identify it is that each one of these terms happens to be a perfect square number. 4 is 2 times 2, 9 is 3 times 3. So that's another good indicator, but regardless of whether you notice it or not, there's no common factor here, so it has to be unfoiled. So you should start this way anyway, and hopefully you'd get to the point where you'd say, well, I know how to get 4x squared. Right? If you know it's the difference of squares already, you know it has to be identical. So you know it has to be 2x and x. Right? 9, difference of squares, we need identical pieces. It has to be 3 and 3. And also, for this difference of squares to happen, I need a negative 9. So I need 1 positive and 1 negative. Right? That's going to make sure the negative 9 happens. It's also going to make certain that the middle terms cancel out. So those are 4 types of foiling. Sorry, those are 4 types of factoring. But in reality, that maybe overcomplicates it. There's only 2 types of factoring that we use and we know right now, and that is, does the problem have a GCF? If so, do it. If the problem doesn't have a GCF, you better start unfoiling. So there's really only 2 routes to take. And that's our recap of factoring. We're going to use that throughout Chapter 7 as well. So make sure we master this process.